So, capacitive dividers similar to the resistive type of dividers, here the ratio we have discussed is equal to number of units which are here as a C1 and C2 being the capacitance which is of higher rating. So, C1 plus C2 by C1 will give you the value of the measuring across the C2. So, in case the voltage V1 is applied, the divided value could be obtained by suitably the ratio into the V2 which is obtained. So, here the capacitance could be anywhere between C1 100 to 200 P. Of example, the stray capacitors to surrounding the objects, that is near the objects, and the influence of the ground should be kept in mind for the voltage dividing ratio. The requirements for the high voltage capacitors are, it should be independent of the magnitude of voltage level, and over a period the aging of the capacitors should not happen. So, no aging effect should be seen, the value will change in case of the aging if the capacitance value changes over a period. So, this is very important, and very small temperature coefficient and small effective inductivity is permitted. So, not lead inductance also here it is reduced because of the use of capacitance. So, impulse voltage measurements using voltage dividers. In case of amplitude of impulse voltage is not very high, if it is a range of few kilovolts, there is a possible for measurement of using appropriately by the probes or using connecting to the digital storage oscilloscope or a catheter oscilloscopes. Probes are available where few kilovolts could be measured up to nowadays probes of 25 to 30 kilovolts are available or for measurements for AC and DC. However, if voltages measured are to be of a very high magnitude, more than 50 kilovolts to millions of volts, in the case for testing and for maybe for research purposes, and then suitable voltage dividers are to be used as discussed, and these voltages dividers could be of capacitive, inductive or resistive type which have been discussed. So, resistive voltage divider, how the resistive voltage dividers particularly for the impulse voltages are connected are shown here. Example, R1 is the higher voltage arm of the resistor, R2 being the low voltage arm of the resistor. So, suitably this value depending upon the cable impedance proper termination has to be employed by using suitable resistors R3 and R4 and with the protection arrangement to measure the value. So, here again R2 and R3 should be equivalent to the value which is a Z impedance, and R4 the value should be equivalent to the impedance. So, suitable terminations have to be used depending upon the cable which is being used for the measurement. So, for measuring impulse voltages the compensation or the cable which is being used have to be properly used with the terminations and suitable terminating resistors or impedances. For capacitive voltages, again for impulse voltages here as discussed C1 and C2, we use resistance R1 at the beginning of the cable for the measurement and how the voltage is obtained. So, this again suitable termination depending upon the impedance of the cable or is being employed. Here this is the capacitive voltage divided circuit with a matched resistors at the head of the terminal of the cable, and this shows the capacitor voltage dividing circuit with the matched resistors at both terminals of the cable. So, you can see here a suitable matching impedance of the cable is used at the beginning, that is R1, and also at the R2 with capacitor C3 which could be obtained here for this could be used for filtering. So, damped capacitive divider we have discussed about this, which is used for the AC and impulse. These are typical damped capacitive divider which is used in the lab, and one of the example of a series damped capacitive divider for a 6 million volt impulse voltage measurement This is being used in France laboratory, high voltage laboratory. Next is the magnetic links. This magnetic links measurement is used for the peak magnitudes of the current flowing in a conductor. So, these magnetic links consist of a small number of short steel strips of very high retentivity, and the link is generally mounted at a known distance from the current carrying conductor. So, the measurement of remanence which is possessed by the link after impulse current as passed through the conductor will enable to calculate the peak value of current. Accurate measurements, it is usual to mount 2 or more links at different distances from the same current carrying conductor. So, because of its very simplicity, relative simplicity, this method has been used for measurement of lightning current, especially on transmission towers. So, the magnetic links are provided on the transmission towers. The magnetic link helps in recording the peak value of impulse current or surge currents, but these give no information about the wave shape of the current. So, that is the importance. The second for the method for current measurements is the Faraday generator or the magneto-optic method. This method of current measurement basically uses the rotation of a plane of polarization in materials, particularly by the magnetic field, which is generally proportional to the current, that is the effect of Faraday effect is considered here. So, the crystal C, you can see the crystal is shown here, the crystal C is placed parallel to the magnetic field produced by a current as shown here I of t, which is to be measured. So, a beam from here, a beam of light from a stabilized source is made to incident on the crystal. See, this light is made to incident on the crystal after passing through the polarizer. P1 is the polarizer here. So, this light beam undergoes rotation in the plane of polarization as shown here. After the beam passes through the analyzer, there is a second analyzer here, polarizer P1, and second P2 is the analyzer. It passes through the analyzer P2. It is further focused on the photo multiplier here F, the output of which again is photo multiplier is here, a filter and a photo multiplier here. So, this is further connected to a digital storage oscilloscope or a cathode oscilloscope, and the filter F, which is shown here, allows only monochromatic light to pass through this photo multiplier. So, advantages of this method being it provides isolation on the measuring setup from the main current circuit, and it is insensitive to overloading. This is the point to be considered. As the third being the signal, as a signal transmission is through an optical system which we discussed. So, no insulation problem is faced. However, this device does not operate for DC currents, that is important point to be known. For measurement of very high power frequency currents, the method which is used are the current transformers and an electro optical system are employed as shown in the circuit here. The high power frequency currents are normally measured using the CTs as shown here, current transformers, as use of low resistance shunts involve unnecessary power loss. That is the reason they go in for current transformers. Besides these current transformers provide isolation for high voltage circuits. So, not directly connected to the circuit and they are safe. So, this arrangement is used for measurement of the high power frequency currents, which this is the conductor which is being carrying the current. High frequency and impulse currents, again impulse measurements, you have two important aspects. One is the measurement using a voltage divider, and the second is going in for the Rogowski coil, or the voltage divider again you call a current shunt here. So, this again is a resistive elements which are number of elements connected in parallel, and it is used for the measurement. So, in power system we know the amplitude of currents which are seen in the transmission network could vary between few amperes to few hundreds of kiloamperes, and here the rate of rise particularly of these currents can be between 10 to the power of 10 ampere second. So, and the rise time can vary anywhere between a few microseconds to a few macroseconds, that is standard impulse currents could be 8 by 28 microseconds the front time and 20 being the tail is a typical example. So, these devices used for measuring such currents should be capable of having good frequency response. So, very important over a wide frequency band. So, general methods are used in the laboratories for the measurements of high frequency impulse currents are the resistive shunts, elements using inductive effects, third is the Faraday and Hall effect devices. So, these are accurate of these between 1 to 10% depending upon the devices. This is a general circuit which is used for impulse current measurement with a cable and again a terminating impedance. So, commonly used method for high current impulse. So, voltage across the shunt resistor R, this is the shunt resistor R due to an impulse current which is flowing through the object is fed to the oscilloscope using a suitable cable and through a delay cable in case required, and it is terminated across an impedance Z which is shown here, which is equivalent to the surge impedance of the cable to avoid the reflection. So, very important. So, dimension of this resistive element is large. So, we will have a residual inductance and a stray capacitance. So, this inductance could be neglected at low frequencies, but at higher frequencies inductive resistances would be comparable with the resistance of the shunt. So, the effect of inductance and capacitance above 1 megahertz usually should be considered. So, in order to minimize the stray field effects, some of the designs as shown here, this is the bifilar flat type of strip, this is the coaxial type of arrangement or a squirrel cage arrangement is shown here. The designs are used as a resistive elements, that is a current shunts, these are different shunts, that is a bifilar type strip current shunt, coaxial tube or a park shunt or a coaxial squirrel cage shunt. So, these bifilar strips suffer from stray inductance effects which are associated with the resistance elements which are used, and the potential leads are linked to a small part of the magnetic flux which could be generated by the current being measured. So, to eliminate these problems of the magnetic flux which is generated and also the resistance say inductance effects with the bifilar shunts. So, coaxial shunts were developed as shown here. So, here current enters between the cylinder of the shunt element and returns through the outer cylinder. So, the space between the two cylinders is occupied by air which acts like a perfect insulator. So, the voltage drop across the element is measured between the potential pickup point and the outer case, this outer case. The frequency response of this element is almost a flat characteristics up to 1000 megahertz, and the response time is a few nanoseconds. So, that is the reason these are being used. So, the upper frequency limit is governed by the skin effect on the sensitive element. One of the important measurement used for high currents is the Rogowski coil. Rogowski coil is used for the current measurements. The current to be measured which is flowing through a conductor surrounded, you can see the conductor which is surrounded by this coil. The current which is flowing in this can be measured with the help of the Rogowski coil. So, in case assuming M is the mutual inductance between the coil and the conductor here. So, the voltage across the coil terminal is given by Vt is equal to M the mutual inductance into di by dt. So, usually the coil is wound on a non-magnetic former in the form of a ring. You can see the toroidal ring having a large number of turns, several turns are wound on this ring. So, mainly to obtain or adequate voltage which is induced because of the current which is passing in the conductor, which can be measured, that is very important. So, the coil is suitably wound basically to reduce the inductance. So, here the alternative layer, the one which layer starts here, the other in the reverse direction is intentionally wounded, so that to make it non-inductive type of arrangement. So, the consider n number of turns in a coil, A being the area of the coil and Im being the mean length. So, the mutual inductance is given by M is equal to mu naught into Na by Im. So, normally integrating sometimes normally these coils or Rogowski coils could be of integrating, or sometimes if it is required differentiating type of Rogowski coils. So, here the circuits are adopted, suitable circuits are adopted to obtain the output voltage which could be proportional to the current which is to be measured. The output voltage is given as V naught is equal to V naught of t is 1 by RC, the R and C which is used for measurement, integral of V into dt, where this is equivalent to M by RC into the current which is being flowing. So, it is advisable to use the Rogowski coil up to 100 megahertz. Beyond this, the measured values could be affected by the stray electric and magnetic fields or the skin effect due to the conductor. So, further to the measurements, recent advances or developments have been happening in the measurement of the high impulse currents, where digital transient recorders particularly for the impulse measurements are being used. Here the recent technological developments have made the use of high speed digital recorders possibly in the field of high voltage impulse measurements. So, the use of important advantages over the use of traditional analog oscilloscope or recorders is to obtain impulse test records in digital form, and this allows introduction of wide range of digital signal processing techniques into the analysis of high voltage data which is being collected. So, these digital transient recorders techniques enable high voltage test engineers to make suitable correction to the errors due to the non-ideal voltage dividers. So, to eliminate the effects of slight variation in the form of applied impulses in successive test records, and also to perform statistical analysis on the results for long series of impulse tests which are conducted. So, some of the principles and how the historical development of this transient digital recorders have evolved and how it is important. We see that although digital techniques were available for many years, only over a last decade these are used for measurements of high voltage impulse tests, which have become more important in analyzing the data and also the recording. The first attempt of digital recording of non-repetitive pulse was undertaken in late 50s in order to enable online processing of the recording of the transients in the power system network. So, this idea initiated the development of use of recorders which formed functional basis of the present day scan converters. So, somewhere in 1970s electronic circuits utilizing the solid state components for the high speed analog to digital conversion came into use. So, since then several mechanisms for realizing the analog to digital conversion process is being implemented. So, there are 4 basic analog to digital conversion schemes which are utilized in the present day high speed digital recorders. So, one is the scan conversion, the second is the charge coupled device storage, the third is the flash conversion, and fourth being the ribbon beam conversion. This is one of the example of using the digital recorders for the measurement of the impulse voltage. This is the impulse generator, you have a divider, you have digital recording unit for the measurement of the impulse voltage. So, the data can be monitored, carefully analyzed, and it could be used for the interpretation. So, this is again use of the digital AC DC peak voltmeters and recorders for the impulse measurements with other type of digital recorders. So, there are mainly for the measurement of high voltage impulses we have 2 important, one is the digital impulse analyzing system and the second being hybrid impulse analyzing system which are having a very good capability of capturing the information from the impulse and which will help in proper analyzing and the interpretation of the surges which are applied to the high voltage equipment. This is again one of the example which is being used, the digital recorders or computerized measuring systems being used for the measurement of partial discharge activity. So, you can see the digital recorders have come in a long way for the help particularly in the high voltage measurements. So, this partial discharge from the divider and the coupling capacitor, you have a measuring impedance here, the measuring impedance it is connected to a monitor of the digital recording system where a proper interpretation with the help of this measuring system could be done. So, during the measurements it is likely to have errors inherent in a digital recorders in contrast to the analog oscilloscope which generally writes a continuous trace of measured signal. In a digital recorder records the and stores only instantaneous values of the signal sampled at certain rate over a finite period of time. So, the input signal is reconstructed by positioning in time according to the sampling rate. So, this leads to the presence of 2 types of recording errors which are generally referred as the quantization and discrete time sampling errors. So, these are often referred to as static errors. So, the requirements of accuracy particularly using the digital recording instruments in the high voltage impulse testing could vary accordingly to the type of tests and also depend upon the nature of test objects. The specifications of ideal analog to digital recorders and the parameters required for impulse testing are in general available and described in the relevant measuring standards for the high voltage test systems. So, final important is the measurement, you have to have a suitable calibration and traceability. These are the important requirements and comparison with the reference measuring units. So, the assigned factor, the scale factor of any measuring system shall be determined by the calibration of it which is done. So, using a comparison method, reading of measuring system is compared for approval with the reading of the reference measuring system. So, both the measuring systems indicate the same voltage V, which is reading multiplied with the relevant scale factor. So, this reference measuring system and this is the measuring system under calibration. So, this both have to be showing the same value, then the equipment which could be used can be traceable to the main equipment, and it can be the results which are obtained can be of accurate in nature. So, calibration and traceability are also equally important for any measuring devices which are used in high voltage laboratories. This is one of the example of conducting a calibration experimentation for the equipments with the reference measuring system. So, with the reference measuring system in case of a divider, this divider which is under calibration is done and suitable equivalence of the reference system is maintained and it is calibrated and certified. So, this is how importance is the calibration and also the comparison which is to be carried out at regular intervals of a time where with the traceability equipment which is situated at different regions of the country or the places which is available. So, the equipments have to be calibrated at regular intervals to check for the accuracy and proper functioning of these measuring devices is very important. The uncertainty which evaluation could be related to the influences which are different from the statistical comparison, this could include contribution to the uncertainty, that is the non-linear effect, linearity effect that is done by the linearity test, and dynamic behavior effect, the short term stability effect, the long term stability effect, and whether the ambient temperature effect for the measurements, the proximity effect of the equipments which are being used, and the software which is being used for the measuring. So, several of these things contribute to the uncertainty in the measurements. So, we will stop here. We have discussed about the measurement aspects. Thank you.